I'll say like flip tabs on the chapter the first semester.
All right, happy Tuesday. How's everyone doing? Yeah, great. Good to hear it. It's nice to be with all of you. We have a really good one for today. We're introducing time series. So we're going to talk about relationships through time. And then next class, we're going to start talking about panel data, which is one of the more, I think, interesting data structures. So we're going to review a bit about data structures here at the beginning before we get into time series. And then we're going to do some visualizations. So we're going to show you some bad visualizations for thinking about data sets with the time component. And then we're going to get into some graphing. So we're going to talk about line plots and thinking about seasonality. So that's what we're going for today. You hopefully saw my announcement about the first mini exam. I scheduled it for September 22nd. So that's not next week, but the week after. So that'll be the Tuesday in 2 weeks from today. And that'll give us plenty of time to get through part one with plenty of time for practice and a bit of review of the general scope for what we've done in part one. And then once we get through part one, we'll take the mini exam, and then we will start in part two. So we'll start working with data structures in different ways. Okay, so that's mini exam. Let's see, homework 1.3 is posted. 1.4, I just checked right before class. The link is broken, so I'm gonna have to go back and fix that. But that'll get posted later today. These, as always, homework 1.3 and 1.4 are just going to be directly on the topics we cover in class. So part 1.3 and 1.4. So the match, as always, is going to be exactly 1-to-1. Let's see. So any housekeeping, anything that I've missed, any questions you might have? You all feeling a little more comfortable with visualizations than at the very beginning of the semester? How'd the last homework go for you? Okay. Actually, can I get a raise of hands? How many of you answered the questions? I'll be able to see this when I go through the assignments, but I'm just curious. How many of you answered the visualizations using Python? And how many used Excel? Okay, about 50-50 split. That seems about right. You can answer any of these questions in the homework when we talk about visualizations or any other type of data work. In parts 1 and 2, feel free to be working with either Excel or Python. They're really identical tool sets in a lot of ways. Like the things we're doing, we are doing in the same ways in Python and Excel. Python just gives us a little bit of an extra sort of reproducibility, and it's a systematic way of doing the same things that we do in Excel, just with code. And it will also allow us to run statistical tools once we start hitting part 3, part 4, and part 5. So eventually we will be turning our attention almost entirely to Python for those statistical tools. But a lot of people actually use Excel alongside Python and use both tools. So that's definitely a way you can work with data. This is a shot from the weekend. We went on a walk and we both had sunglasses on. All right, did I mention I had a child this summer? Okay, so this is where we're going today. We're gonna do a bit of review on data structures at the beginning here, and then we'll do sort of a warm-up exercise, and then we're gonna start working directly with time series data. Okay, so you'll remember this from the very beginning of the semester. We were introducing the dimensions of data. So we talked about different variable types, categorical and numerical primarily. And then we also talked about the number of variables we have in our data sets. And so far what we've covered in part 1 is univariate data. So data where there's one meaningful variable. We also talked about data structures. So we said there were generally 3 main types of data structures. And these are the 3. We've spent the semester so far talking about cross-sectional data. So this is like the survey that we gave at the very beginning, which is like, I just look out into the world, I see a snapshot of things at a particular time, and then I can look across people or across entities, so like across states or across countries at one point in time. This is our cross-sectional data. So like household income in a particular year would be an example of that. Today, we're turning our attention from cross-section to time series. So time series data is a little bit different. Instead of thinking about one snapshot in time, we're thinking about one entity through many periods of time. So what we're going to look at for most of class today is prices. So prices in one market for coffee, essentially. And this is multiple snapshots through time, but of one entity. So we're looking at one thing repeatedly through time. So the variability is instead of it with cross-section, the variability is not across observations, but across time. And then panel data is sort of the combination of these two things. So we have in panel data, as you'll see, maybe next class, with panel data, we're looking at many observations through many periods of time. So it's sort of combining the variability in cross-section with the variability in time series. So an example of panel data would be something like household income over time. So if we have many observations, many households, and we see each household at many periods through time. Okay, so I've given some examples here which may give away some of the answers to the first exercise, but this is sort of how we think about data structures. We spent most of the semester so far talking about cross-section. We're about to talk about time series, and then soon after we'll talk about panel. And then geographic is just a different type of thing entirely. Okay, so we have 3 data sets here, and we're going to jump into the exercise just right off the bat. Once we get through classifying data structures, we're then going to actually start working with time series and think about best practices for summarization and visualization of time series data. All right, so you can hop over to the notebook. Still haven't watched the movie this semester. I've also gone ahead and posted some notes. I think this link works. So if you want to take a look at the notes that I use sometimes for preparing for the class, these are just some things I've written up, and you can take a look at those if you like. I haven't posted them in past semesters, so let me know what you think. Okay, so we're going to work with time series data. You can click on the link here, which will bring up the notebook. And you can also download the data sets directly if you like. So we can just download them. So the first data set we'll work with is this household income data. So I'm going to open this in Python. So we're just going to run the imports and then the file path. And then what we could do is just plot the data set directly. So if you wanted to in Python, this is the way I would do it if I was working with a notebook like this. We have the data set here directly. If you want to do this in Excel, you can download the household income dataset with the link I gave on the website, and we can look at what's contained in the dataset. Okay, so our goal here, just as a bit of a warm-up, is to try to classify what data structure this is. So we know there's an income variable which is numerical, but we know some of the and then we have household income and year. Household income would be categorical. So we have our variable types classified, but what we want is to choose one of the three data structures: cross-section, time series, or panel. And we're gonna try to classify this. So open the data set up, take a look at it, and then I want you to tell your neighbor what you think the data structure is. We'll take about a minute for this. And then I'll ask someone to give me a wrong answer in a second. All right. If you're still trying to classify this, keep going. You can always talk in class. Like if you have questions with someone else about the material in class, I strongly just keep talking to each other. That's great. Just turn the volume down a little bit so we can focus on what we're covering. But feel free to keep talking. Someone tell me what data type this is, and I'm looking for, data structure. I'm looking for wrong answers. What is this? What's the data structure? Is it Luke?
Yes. You want a wrong answer?
I'm looking for a wrong answer.
It's a time series.
Okay, so why is this a time series?
Well, a time series is multiple times, but it's 1 minute.
Okay.
So this is hard because I just want to get the right answer.
Yeah, so correct. You are correctly incorrect. It is not time series. Someone give me a correct answer. Luke answered the question correctly, but also incorrectly. Yeah. Panel. And why is it panel?
I don't really know, but that's just what the example is on the slides.
Ah, so using the slides. Someone other than Luke. And remind me of your name?
Alexis.
Alexis. That's right. Someone other than Alexis and Luke, tell me why this is panel. Okay, nice. So we have multiple time periods. So in some sense, Luke was correct. There is a time component to it, and you can see that even with year. But we also have multiple households. So you can see there's household 1, so H001, and you can see there are multiple observations for the same household through time. So you can see their income as it changes. But then we also see a second household at another point in time. So we have multiple households being observed through time, and we have one variable that we're tracking. So both cross-section, so multiple households, and time series, multiple periods of time. So this is panel. Okay, any questions here? Next class, we're going to think about methods for summarizing panel data. It's obviously the most complicated of the three. What about this one? So the second data set is household savings. So you can download this if you like, or you can load it in the notebook. Let's take a minute here, try to classify this, and then I'm going to look for not just a wrong answer, but also a justification for why your wrong answer is correct. Okay.
Doing this. Because I just
Can I
love
exit
that-
all this?
Yeah, you can do whatever you need to do. Because I just love the way that like in the notebook and then trying to figure it out. And I was like, why is it like this?
Yeah, I've never seen that before. Let's restart. Okay. Nice.
Okay.
Should be all set. Okay. Someone tell me incorrectly what the data structure is. Someone other than Luke. Yeah.
Is it a wrong answer or?
I'm looking for wrong answers only.
Okay. Time data, time series.
Time series? And why is this time series? That's a really tough question to answer. You could say this is time series because there are multiple periods of time in this data set. Incorrectly. Remind me of your name?
Joe.
Very nice, Joe. Someone give me a right answer now. Ruby.
I think it's cross-sectional.
Okay. And why is it cross-section?
We only have several households, but we only have the savings at a certain period of time.
Yeah, nice. So we have one sort of snapshot of many people. And we can see this, just as Ruby is saying. I say saying and write savings at the same time is complicated. So we have multiple households, and no household repeats, it looks like. And then we have a savings rate. So it's just really an observation across many individuals, and it looks like it's one period of time. Okay, yeah, so this is cross-section. And then we're going to do the last one. So you can use deduction to figure out which one this is. But let's actually just look at it and try to figure it out if we hadn't already looked at two others. So the last one is monthly copy prices. We'll take about a minute here. I want you to take a look at this data set and then try to classify it. And then I'm going to look for a correct answer, strangely. Go. Okay, someone tell me what data structure is this? Yes, is it Sophia? Time series. And why is it time series?
Because it follows the same type of copy over and over.
Nice. So, so what we can see here is we have multiple dates and one variable, price, that we track across time. So the dimension of variation is time. So we call this time series. Okay, any questions here? So today we're going to spend essentially the rest of class talking about time series, and we're going to get familiar with best practices for thinking about how to set up a time series. This will probably feel very intuitive, and then we're going to talk about different ways of looking at the series itself in more detail. So we're going to work with this coffee prices data set. If you're thinking about, so if you look at the data set, you've already loaded it, and you're thinking about how you set prices in January, let's say, of this year. This is a data set that has information about historical prices, but it doesn't give us a prediction about the future. If you're thinking about how to use this data set to inform your decision about how to set prices in January, one thing, at least historically in this class we've done, is take a numerical variable and summarize it using a histogram. So what I'm going to do first is just create a histogram of all of the prices in our data set. So if you wanted to do this in Python, you could just write out, sns.histplot data, and then the x variable would just be the price. And that would give us a figure that looks like this. If we're thinking about how to set prices in January of 2026, how would we use this? If you saw this, what would you do when you're setting your price in the future? Yeah.
I would use the data from year 2025 and try and price my coffee competitive to where I can sell it off.
Okay, so we have to think about sort of the more recent data, right? Like, so instead of looking at the entire historical trend, or the distribution of prices going back to the 70s, we want to do something about more recent data, right? Remind me of your name?
Joe.
So Joe is saying, I think sort of implicitly, like, this may not be the right visualization tool to answer our question. We can't tell what's most recent. There's lots of data in this histogram that just probably isn't useful to us. And it's really essentially impossible to see using a histogram. So a histogram in a lot of cases is very powerful, but when we're talking about a time series, a histogram actually sort of obscures some of the most important components of the data. What Joe's recommending is we look at the most recent data. So anyone know how we do this? How do we set up something that tells us what's most recent? What if we take each individual data point, place price on the vertical axis, and then place date on the horizontal axis? So we're just going to plot a bunch of points and plot them against time. So maybe this actually is sort of in line with what Joe's recommending. Let's think about the most recent data. What do y'all think of this figure? Do you like it? How many of you think this is more informative than the last one? Yeah, I agree. And how many of you think we can improve it? Yeah, I agree with that. I think we can probably improve this. Any suggestions for what we might do? Yeah.
Maybe like a line of best fit?
Okay, so one thing, and we're going to talk about this actually quite a bit starting in part 3. We haven't really talked about lines of best fit yet. We will. What a line of best fit would do is just draw a line through the data points, minimizing the difference between the line and the data points directly. And we will get there. Remind me of your name? Chase. What's before we start talking about statistical tools, what's a thing we could maybe do to improve this figure? Yeah.
We like clump a bunch of them that are relatively like near each other to maybe like a bar graph or something.
Okay, and we're actually going to do something very similar to this later in the class period. The idea is maybe we'll try to, there's a lot of variability here. There's a lot going on. And maybe what we'll try to do is try to summarize different regions of the graph. And then maybe use bars or something else. I'm going to actually recommend a box plot for that kind of tool. When we use a scatter plot like this, where we plot each individual observation at a specific point in time, we're sort of subconsciously seeing each individual observation as a separate entity. So when we plot dots like this, it looks like each one of these prices is separate. One thing we can do to improve this figure is communicate to whoever the audience is that these are actually repeated observations through time. So they're essentially connected. They're the same observation, but through time. And one thing we could do with this is create a line. A line graph is the main time series tool that we're going to work with. How many of you like this one better? Yeah. How many of you like this worse? How many of you like the other one better? I think a line graph actually communicates much more clearly the main point of time series, which is that we have repeated observations. So it's the same unit of measure through time. So it's essentially connecting the points together to tell us that these are one connected thing we're measuring. Okay, and I think this also communicates what Joe was saying, which is when we're thinking about how to set prices in 2026, we want to look at the most recent data. This is 2021, so maybe this would be a different year. When we're thinking about how to set prices in the near future, we want to use the most recent data. So there's some important component to the time. So more recent data is more interesting, more useful to us. So my next question is, do you notice a trend? So sort of a pattern through time. Anyone want to summarize this? Is it Chase? No. Yeah. Remind me of your name. Jason.
There's more like a positive relationship.
Okay. And how do we see that there's a positive relationship?
The line is steadily increasing throughout the whole year.
Yeah. So Jason's saying, look, as time progresses on the horizontal axis, we see an upward movement in prices. And this looks pretty consistent, right? So we start off in January, and then we see a general upward, what we call trend. So we see a generally positive trend here. Although you can see there's variability, right? Up and down movements within a larger trend. Any other observations here? Yeah.
I don't know if this is correlated to the trend in price, but you can kind of see that as it's going up, that's also like, say, seasonal times.
Okay.
Is typically when there's like that would spike.
Yeah. So you're pointing out like these little jumps?
Yeah, once you start getting into like the later range,
Uh-huh.
I kind of see a jump, which is also like fourth quarter for a lot of companies, which could contribute to higher prices.
So this little area here.
Yeah.
Okay. Yeah, so like November we start entering, at least in the US, we start entering like our main holiday season. And also, I don't know about you, in the winter I drink more coffee than in the summer. It's darker, maybe it's nicer. So maybe as demand rises, so does price. Yeah, so interesting observation. And we're actually going to talk more about seasonality in a second. Remind me of your name?
Sophia.
Two Sophias. All right. Okay, so yeah, so we can see a general trend, generally positive this year. But one thing we often want to do is get as broad a picture as possible. So one thing we can do with the time series is not just look at specific intervals, but try to look at the entire range. So I'm just going to zoom out to 2000. So what I've done here is plot all of the coffee prices between 2000 and 2025, so roughly today. I guess it was the end of last year. And what do you notice here? Where does our previous figure fit into this graph? So just 2021. What are some general things you notice with this interval? Ruby. Yeah. Yes, so right around here we saw a massive increase in the price of coffee, which happens to correspond with the previous figure, right? So this was only the year 2021. We went from $1.25, basically doubling the price of coffee, to $2.50 during that time. And you can see that corresponds with basically starting here, jumping all the way up to $2.50. So our narrow focus actually happened to capture something pretty extreme. Anyone have a theory for why prices jumped during that time? Anything else going on in the world in 2021? Yeah. COVID, yeah. So like supply chain disruptions, lots of things got more expensive simply because supply was way lower. Okay, so we have subtrends. We plotted one of them earlier, but you can see other periods here. So like this was right after the recession. Do you notice a general trend here? Like over this longer period? I don't know. It's maybe slightly upward. It starts off, around $1 and then maybe ends, $1.50 to $2. But it's not quite as striking or as clear a pattern as we saw when we just looked at one year. So we saw many periods of increase. We also saw many periods of decrease. One thing we can do if we're trying to communicate not just the general trend, but also subtrends within a larger pattern, we can try to communicate that visually. You may have seen figures like this when we talk about recessions. So you'll see like GDP through time, and then during long periods of decline in GDP, often you'll see figures that look like this, showing in gray bars periods of recession. What I've done here is just color the background at the quarters where we see declines in the price of coffee. I've just colored them gray. And I think this actually communicates not just the time series, but it also highlights something extra about the patterns that we see in time series. So I think this is interesting. We don't do a lot of this background shading, but I think when you're trying to communicate, sometimes this extra bit of information that we set behind the line graph can be useful. It's a little bit harder to construct, but it's definitely something that you can do. Okay, any questions here? So the main points, time series is data connected through time. So when we try to communicate with a figure, when we try to communicate time series, we want to indicate to our audience that this is one sequence of data, one repeated measure through time. And the way we do that is by plotting on the horizontal axis of time, we plot a line, indicating to our audience that it's one repeated sequence. It's one consistent thing we're measuring. And we like to plot against a time series horizontal, against time, to indicate to our audience what's first and what's last, so the sequence itself.